Okay, so we're reviewing for a little quiz on polynomials we're going to have tomorrow. And the main two topics we're talking about are if I give you an equation, what are you supposed to know how to do? And if I give you a graph, what are you supposed to know how to do? On the equation side, if I give you an equation like A or B there, you should be able to tell me the degree and you should be able to tell me the end behavior just by looking at the equation, no graphing. I'll give you a second to answer those, and I'll pause while you do that. So tell me how you think this one through. If this is an even degree of 2, they both have to be the same because it's even, okay? And since there's a negative up front, what does that tell you? The end behavior is going to be down where? On the right-hand side. That's all it tells you is the right-hand side is down. Then, logically, you can say, well, since they have to be the same, then I know this one must be down. Good. All right. Who can handle B? Yes. Degree is 3, correct. You look at the highest degree term in there and you pick that. Now what? Which should I start with? If you were telling somebody, start with the right side, why? Excellent. And is it positive or negative? And therefore, oh, good. So now reason it through for me how you know the left side. She said since it's an odd exponent, it has to be going in the opposite direction. And that's correct. So this must be down. All right. Next is factored form to general form. This is in factored form. How do you get it to general form? Yeah, anytime you want general form, you generally just multiply. So we're just going to multiply that thing out. How do you multiply it out? Well, start with this part. Can you do that in your head? I bet you can. You're getting advanced enough at this. X plus 5 times x plus 5. Foil it out in your head. What would it be? X squared plus 10x plus 25. Good. But now the next part you're not going to be doing in your head because it's just got too many parts. Do you remember? I called this the giant clam technique, where you go this times this times that, and this times that, and this times this, and this times that, and this times that. And it sort of looks like a giant clam if you squint your eyes and use your imagination. So that's 6 little parts to it. Would you please multiply those out right now, put them together, and you'll have the answer for general form. I'll pause while you do that. Okay, so you get the 6 things. I've got 3 in blue and 3 in green. The ones I did in blue there were from the x, multiplying the x out into everything. And then the things I did in green were when I distributed the -1 to every term. And now I'm going to put these things together. I have an x to the third, and I don't have any other x to the thirds, and therefore it's all alone. X to the third plus, do I have any other x squareds besides the 10x squared? Yeah, I do. Minus an x squared. What does that make total? 9x squared. And then I got a 25x and a negative 10x. What does that make? 15x. And then I have a 25 here, and it's just a loner, kind of like that x to the third. There isn't any other, so I can just put it down. There we go. Raise your hand if you had that one right. Vast majority of the class. Good. Now, if you had it wrong, hopefully you can see where you made your mistake. Now, if I look at this, compared to what I started with here, can you see how some people would have thought it was a degree 2 when they started the problem? It's an easy mistake to make because you see a 2 there and you're thinking, oh, it's degree 2. But really, there's a 1 here also, which makes it a total of a degree 3, and you can see it much better when it's in this form. What form is this in again right here? General form, that's right. Okay, that's some stuff you'll have to know how to do on the quiz tomorrow. Here's some more stuff. If I give you a graph, here's what you should know. The end behavior, that's really easy. What is it? I'd say down, up. I assume you're saying that on the left is down, on the right is up. And absolute mins, those are the low spots. Tell me one. -1, -6 is a low spot right there. Very good. What else? Wait a minute, I don't have the local mins listed. Oh, I screwed up the end behavior. I put that in the wrong spot. Okay, hold on. There, put that up there. And now I have room to just write what you said. Traxler, what did you say again? Good. And then there's another low spot. Let's go with Haas. Yep. Okay. Absolute min. The lowest it'll ever be. You could say none. Because you could say negative infinity, but I'd take off half credit because you're saying that you could get to that place and you really can't. So there's no minimum or none. Local max, that's the little high spots. Everybody be ready. I'll call on somebody. Chaz. Negative 5, 2 is correct. And let's go into the back. We'll go with Garibaldi. Good. And tougher follow-up question, absolute max. They both go to 2. Shouldn't I be picking this one or this one for the highest of them all? No, because it goes higher over here. And we don't know when it would stop, so we'd say none. And the last area is increasing and decreasing. Those are probably the hardest kind because you have to write them in interval form. I'll just do one of them here. I'm going to have you do one in a minute. But if I'm going to write an increasing one, that's like from here to here. It's increasing from, well, where does it start increasing from? Way over here. In fact, infinity over here. So negative infinity to all the way up to right there, which is at what? Negative 5. And I put a bracket around that one and a curve around that one. Yeah, that gives you the idea on that. All right, I'll have you do one of those in a minute. Next thing, types of roots. There are 3 kinds of roots, and the one's really hard to do. Those inflection ones are really hard to do. Can you tell which one I was trying to do an inflection on? The one on the 1. That's where I was trying to do the inflection. And if you're ever looking at one and you're not sure, are you trying to have an inflection there or not? Well, you could, if you didn't have a teacher around to ask, because I would tell you on the test whether or not I was trying for an inflection on the drawing. You can always just say, is this increasing the whole time? Yeah. And is it increasing at different rates? Like, does it go from increasing at an increasing rate to increasing at a decreasing rate? That's how you can tell. So you'll look at like this little section of it, and that's increasing at a decreasing rate. And you look at this section, which is kind of curved this way. And that's still increasing, but it's increasing at a increasing rate. So if it changes what type of increasing it is, then it's an inflection. Okay, so what kinds of roots are there? There's single roots, like that's a single and that's a single. There's double roots, which are also known as a bounce. And there's this kind, which are triple roots or an inflection. All right, so the hardest part, writing the equation in factored form. So this root right here needs a like factoring. It needs a factor, okay, for that root. And the root's negative 7, so I'm going to say x plus 7, so that negative 7 would solve it when we were setting it equal to 0. Then I put squared, shouldn't have. I should put something here, and that stands for, that's called the multiplicity. And the multiplicity is either a 1 or 2 or a 3. Okay, that's for a single, a double, or a triple. All right, so this first one here is a cut through, so that's a single. So I put a 1 there. The next one is for this guy right here, and that's a x plus 3, and it's a single again, because it's a cut through. The next one's supposed to be an inflection for this guy over here, so that's x minus 1, and it's supposed to be a triple, because it's supposed to be an inflection. And the last one is this guy, and that's going to give me an x minus 4, and it's a bounce, so it's squared. Okay, so I put a y equals at the beginning, and the only other thing I got to check for is look at the end behavior on the right-hand side. Is it going up? What does that mean? What does this mean about my equation? That it should be positive, so I don't change it to a negative. If it had been going down, I would have slapped a negative in there. All right, now, I've got one for you to try. There is 11 questions, and I'm going to pause while you answer it, and then I will put up the answers for the people that are following along at home. So here's the answers up to factored form. And then to write it in factored form, we have 3 roots, one for each of the 3 factors, one for each of the 3 roots. And I'm going to pause while I write those down. The leading coefficient is positive because on the right-hand side, it's going up. as it ends.